Linear differential equations are equations that involve a function and its derivatives. A first-order linear differential equation can be defined as frac dy dt plus pty equals gt. This equation's solution can help in various fields, such as physics and engineering. The typical first-order linear differential equation is expressed as frac dy plus b, where a and b represent constants. This defines a linear relationship. Another important form is the general first-order linear differential equation, frac ty equals gt. Here, p and g are functions of t. Let's solve an example linear differential equation. 4 plus t2 frac dy dt plus 2y equals 4t. Our goal is to apply the integration factor method. To solve this, we rewrite it as frac left at 4 plus t's 4t. Next, we integrate both sides to find the solution. Integrating yields 4 plus t to y equals 2t2 plus c. We can now isolate y to complete our solution. The general solution is given by y equals frac 2t squared 4 plus th plus frac c, where c is a constant determined by initial conditions. In summary, we learned about first-order linear differential equations and how to use an integrating factor for solutions. These equations have real-world applications in various fields. Be sure to explore further and practice different problems. Thank you for your attention. Keep practicing your understanding of linear differential equations.